Friends, we have heard about balance of forces where more than one force is acting on a body, and actually they are acting in such a way that their sum total is zero or their net force is zero, and they are actually balancing each other so that the body is in equilibrium. They can be 3 or more than 3, and their angles would be and location would be in such a manner that their resultants is 0, which we are now going to show through an experiment where 3 logs have been hung to give weights which are actually giving tensions in the 3 strings, and the tensions in the 3 strings are directly showing us the direction of forces. The set of strings is in equilibrium, and at the knot the 3 tensions are acting at 3 angles in such a manner so as to completely balance each other and keep the body at rest. So we will now see how the forces are acting. If I disturb it, the strings achieve their own balance, they shift so that they can remain in balance. So with the help of our understanding of vectors, we will see how these forces are acting. So here I will take a pen showing the direction of one force or tension force, the direction of another tension force in this string, and these 2 forces have to be in such a manner so that they oppose the third tension in the third string in the opposite direction. So the resultant of these 2 forces will be in this direction shown by the red pen, so that it is opposing the third one and keeping the set in equilibrium. So this is actually a practical demonstration of vector addition, which we can see in any other set of these forces. So here we will do it with another set. So these 2 tensions and the resultant is in the third direction, which is opposing the third tension in the extra string. So the system is keeping itself balanced. Similarly, for the next set, the 2 forces and the resultant, and which is opposing the third force. So this is how the strings remain in balance, and the angles have been made by the strings themselves in such a manner so that they achieve a state of balance. They pull at each other in such a manner. So if I try disturbing the system shifts by itself to achieve the balance. Once again, seeing how 2 forces here are giving a resultant in such a manner so that it is balancing the third force. So any shifting or any movement leads to the strings themselves going to the equilibrium position because they are free to move. And here it is important to see that the friction at the edge of the table should be very less for this experiment to work properly. So that's how we practically see balancing of forces in a system.